Okay, this is the beginning of video A5. It's really lesson 7.3. And if you haven't figured it out yet, we are in unit 10. I guess I should put that on here. And today we begin to learn about logarithms. All right, and so we can see why we want to learn about logarithms. Think about this. If I gave you an equation, 2 to the x equals 8, you could easily solve that. You know that 2 cubed is 8, and so x is 3. But what if I had given you the equation 2.73 to the 5x minus 4 equals 73.8, and I said I want the answer rounded to the nearest tenth. Okay, a much more difficult problem, and so we need some method of solving for x when it's the exponent of an exponential equation. Okay, and so what we need is the inverse of an exponential. Okay, just like if you had 2x equals 4 to solve for x, you would divide. You would divide by 2 because division and multiplication are inverses. Had you had x plus 2 equals 4, you would subtract because the inverse of this addition is subtraction. So there must be some way to undo that exponent. And that's what we're going to learn about right now. We're going to ease into it. Okay, and so what I'm about to write down is simply a definition of what a logarithm is. Okay, and it goes like this. If I have a equals some power, okay, b to the x, okay, the associated, this is exponential now, the associated logarithm looks like this, and I'll show you how you can easily find it. We say log base b of a equals x. And even though you're not giving me any feedback, I do want you to use the proper language, even when you're just thinking about this. So to read this, we say log base b of a is x. Okay, and so this logarithm is what we're going to use to undo this exponential. Because look, the x is all by itself now. Okay, so the first thing we want to learn to do is just simply convert from exponential to logarithmic form, and it's a very easy trick. I'm going to mess up my notes now. What you do is you find the base, and the base is b, and circle it. Okay, and then I'm going to use these words often. Some people call this the log circle. Okay, what I want you to do is go from that circle, go across the equal sign. So you go across, and then you come back to the only part you haven't dealt with yet, the x. And then, you know how we started with the base? Okay, you read it by starting with the base like this. Okay, log base b of a equals x. And so you see we have that, log base b of a equals x. Okay, so let's go ahead and practice converting. So I have 2 to the 6th equals 64. Okay, that's true. Okay, but what I want you to do is I want you to convert this exponential into a logarithmic. And so we circle the base, we go across, and we come back. Okay, and then let's go ahead and see that. So remember, we started with the base, and so we start with the base. Log base b, base 2 now, of 64, and then we come back equals 6. Okay, and so that's exactly what we did up here, but let's say I had given you the logarithm at first, and I said convert it to exponential form. What's nice about this is you use exactly the same words. Okay, so in a logarithm, if we want to convert this to exponential form, Okay, we circle the base, we go across, and we come back. Okay, and so let's look at this and do just that. So find the base. Remember, the base of a logarithm always goes right here. This is the base. Okay, so circle the base, go across, and come back. And then since we start with a logarithm, we read the converted one as an exponential. And you always start with the base. So we have 2 to the 6th. And then we come back equals 64. And of course we end with what we just started with. Okay, let's try it again. Let's do something very simple. 10 squared equals 100. Okay, so let's convert this. This is exponential, so if we're told to convert, we must be converting to a logarithm. So I'm going to circle the base, I'm going to go across and come back. And then I'll read it. It's exponential, so when I convert it, I'll get a log. So I get log base 10 of 100 equals 2. Okay, and if we needed to, this is the last time I'm going to do it both ways, but we could convert back to this by circling the base, going across, and coming back, and note that we get what we started with. 10 squared is 100. Okay, so let's go ahead and make it a little more difficult. And let's do log base 10 of 1/10 equals, and up here, had I said 2 to the 6th equals, you guys could have all told me that it was 64. 10 squared, you could have told me is 100. So let's think a little bit about this. What would this equal? Okay, so notice in our logarithms, okay, here, log base 10 of 100 means 10 to what power is 100? Log base 2 of 64 means 2 to what power is 64? So here, this is saying 10 to what power is 1/10. And I'm hoping you guessed -1, because that is true. Okay, and so let's see that it is true that the log base 10 of 1/10 is -1 by converting. So circle the base, go across, and come back. Okay, and then write it. Since it's a log, we'll convert it to an exponential, and I get 10 to the -1st equals 1/10. Okay, and so maybe one thing I need to add up here now is what value that b can take. Okay, and now that we've done a few, maybe this will make sense. Okay, we want to only deal with bases that are greater than 0, but not bases that are equal to 1. Okay, so think about that. Like if I had, I'll just do this off to the side here. If I had log base 1 of 12 equals. And so this says 1 to what power equals 12? That doesn't make sense. Okay. So the b can't be 1. The base isn't negative, just like with our exponentials, we were dealing with negative bases. Okay, but let's talk about what a can equal. So let's say I have log base 2 of -4. Okay, this says 2 to what power equals -4. Here, let's actually write that like this. So 2 to what power equals -4? Well, if you raise 2 to any exponent up here, you're not going to get a negative number. You might get a fraction, you might get 1, but you're not going to get a negative number. And so what this tells me is that a is not going to be a negative number. Here, I'll write this differently in a little bit. But let's see if a could be 0. Log base 2 of 0 equals x. Okay, so 2 to what power could equal 0? Well, nothing. Okay? 2 to a negative number is a fraction. Like 2 to the negative first is 1/2. 2 to the 0 power is 1. So a must not be able to be 0. So what we'll write is a has to be greater than 0. Okay, so what I want you to do is I want you to try these problems. I forgot to write them down ahead of time, so I'll write them down right now. Okay, and so let's do this right here. So this is problem 1 for your homework. Let's convert. Okay, let's convert 2 to the negative third equals 1/8. So you're going to convert that to a logarithm. Let's convert 5 to the x equals 3. Let's convert log base 2 of 8 equals, and I'm kind of hoping you know what that equals. So you know what, I'm going to leave that blank. So you're going to convert it. Once you figure out what this equals, you're going to convert that to an exponential form. Okay, let's try log base 5 of 1 equals, and I'll leave that blank too. And these are getting a little more challenging now. Let's do log base 2 of 1/16 equals, and figure out what that is, and then convert. Okay, and then the last one, convert 1 to the 5th equals 1 to logarithmic form. Okay, so what we'll do is I'll start the next video by showing you the worked out solutions to all this. Good luck.